Hello everyone. Welcome to this session about packet sniffing for admins. First of all, like you may hear, I'm French, so sorry for my accent. My name is Yoann Gini. I work as a freelancer, as consultant and trainer about system administration, network administration, and also software development. You might have already used some of my software, some about OS X server, for example, to administer, to configure radius or VPN services on OS X servers, or also another one about accessing the password database of Apple Remote Desktop, things like that. Oh, one user? Yeah, thank you. You may find me on a different mailing list about OS X server security, smart card things, and all kind of advanced and undocumented things about OS X server. And for this session today, we will go from the basics. We will remember the OSI model to understand what's going on the network, how does it work, and with these basics, be able to understand how we can do a traffic interception, how we can interpret it, and in which case it's really useful to use that as a system administrator. And at the end, I've got some example from a real situation I've encountered and a situation from other friends, and some bonus at the end. So, to start the session, I would like just to show you a real customer request I got once from a company I just never heard about before. They just sent me an email and say, oh, we have a problem with our smart card setup. It don't work. Here is the packet dump. Can't you do something for us? Just crazy. The first question we may ask is, why? You don't have any log file usable? Something was made for human, something else than a packet dump? Well, in some case, packet dump is the only interesting information. You may have an incomplete log file by design or because of a problem due to hacking and things like that. You may don't have access to log file, or the log file don't exist at all for what you are looking for. And you may also have a lack of trust. Lack of trust in the people who are giving you the log file. Because the people is unskilled, so he may don't have read all the log file that you are looking for, or maybe because it's a company who are covering their own mistake. So in this kind of case, that will lead you to trust only the raw information. You want the raw information and take your and do your own interpretation. That's the main idea behind packet sniffing. It's take what is really happening and try to understand it to make your own idea about what's going on. Another question is how? How can I do that, and where in my network? For answering this question, we need to review the OSI model. It's basically the map of your network. So it's a conceptual model, but if you look at the TCP/IP stack, it's more or less like that. So it's a really good map to start when you have something to do with your network. If you remember the OSI model, you have 7 layers coming from the physical world to the application world, and it can be cut in 2 parts. The layers at the bottom are related to the media. It's something where mandatory to transport the information from a point to another. The upper layers are more related to host. They are not mandatory for the network it can be used by the network, but it's not mandatory. It's used by the host to put the information inside. For each layer, we can have a specific lexicon, specific word to describe information at this level. And this can be useful to use a good word to be sure about which level we are talking about. At the physical level, we have the smallest unit possible with the byte. We can be represented in multiple ways, but it's basically just a byte. When we have enough on it, you're gonna create a frame used at the layer 2. And inside this frame, we will find a packet for the layer 3. And inside this packet, a segment for the layer 4. And upper side, we don't care, it's just data. From a network point of view, what is upper the level 4 is useless. It's just payload. And we don't really care about what is it inside when we are looking at the network. If we take some real example, for example, a serial communication. Serial communication use point-to-point protocol. If we look at the implementation of the point-to-point protocol used to transport an IP communication, we have electrical level at the lowest level. At the layer 1, we use electrical level to represent the information in the physical world. And the PPP standard is used to create this level of information. So basically, what we are gonna see on a network, on a serial cable here, is electrical levels representing PPP frame. And if we look inside this frame, we will see an IP packet. And inside this IP packet, a TCP or UDP segment, and inside that, raw data. Now, if we pass from PPP to a gigabit Ethernet communication, so 1000 base T, the only thing we change is the layer 2. We still use electrical level to represent the information. We still have an IP stack over. And at the layer 2, we use the Ethernet standard to create our physical information. Now, if we change to a wireless system, again, the upper side don't change. We change only the two lowest layer. We use radio signal to represent the information on the physical world, and we use 802.11 standard to create it. But above that, it's the same. It's also IP and TCP UDP. So, like you may guess it, what we gonna look today, it's what happened on the level 2 and 3, depending on what we are looking to troubleshoot. If we are looking for an IP-related problem, we're gonna look at the level 3. That's what is interesting for us. It's if we have a problem linked to the media, for example, a wireless client who can't connect to its access point, or a PPP communication who don't work well, who don't success to authenticate, for example, we're gonna look at the layer 2. So this is basically the map. Where do you want to look, and which kind of information are you able to grab? To intercept this communication, to make your dump, you have multiple options. And again, the start point is look at the map. Basically, your network can be drawn like that. You have your endpoint, client and server. You have your media, your wire used to transport the information. And in the middle of that, you have one or more network node, who can be switch or routers, or access points. Each of these parts of the network can be used to do a network interception, a traffic interception. On the endpoint, you can use the well-known tools TCP dump, which is really useful because it's built in OS X. So every OS X and OS X server already have TCP dump. So it's really nice. You can use it directly on any OS X system without to have to add anything on it. And TCP dump can be used in two modes. The first one is not really useful, is to display the information directly. So you will have, like in this screenshot, the hexadecimal information and an ASCII representation. And unless you have a network parser in your mind, I think it's completely useless. What is going to be more interesting, it's the write to file mode. You can use TCP dump to grab the data and write it on a file and be able to read it later with more useful tools. If we try to do that, okay. So on my MacBook Air, my main interface is the wireless one. So the BSD name of the interface is EN0. What I'm gonna do is just say, okay, TCP dump, listen on the interface EN0 and write to file on the desktop. And the extension used for this file is pcap for packet capture. And that's just all. We have seen it start to create the pcap file on the desktop. I will do some network traffic. It won't impact my network traffic, so I just do whatever I want. And when I've done, I just have to hit Ctrl+C to stop it. Now, we have been able to grab the data coming by and for the endpoint. So we need a way to read it and to understand it. For that, the best tool available today is Wireshark, with a really great tool. We have 1,377 protocol built inside. So that means almost any kind of protocol you're gonna have on your network, Wireshark is able to read it and display a meaningful information to you. You have access to the raw information, but also you have access to interpreted information via Wireshark. So it's really useful for that. And for example, if we look at the packet dump we have just done, we can open it in Wireshark. And here is your communication. So here I see all the information who have been exchanged on my network card. So we see many things. And since we all use OS X, we see a lot of MDNS requests. And we can use it to search to the content. For example, I only want HTTP request. So I can filter it and see what kind of requests have been done via Safari and inspect each of these requests. So here I got all the information on my IP packet. So I see on my Ethernet frame. So I see the information related to the frame. I see the information related to the IP packet. For example, which version of IP packet I have here. What are the QoS? What QoS flag does I have on this IP packet, etc. So if you have to troubleshoot QoS problems linked to voice setup, you can see here if your IP phone is correctly setting its QoS flag. And you can go down inside the packet to see the TCP segment, what information, what port, source and destination. And of course, you can end up to the protocol used in the end. So here it's HTTP. And you can have access to all kind of information linked to your protocol. So Wireshark is really helpful here because it's gonna show you all the information and all the information already interpreted. We will see more usage case after. Here we have done the simple option. We have used software on our endpoints to grab our data. We have some other solution, and one is on the network node. On a network node, on most managed switch and managed router, you are able to set up what is called port monitoring or port span, depending on the constructor. And basically, the idea is to duplicate a flow passing by a specific Ethernet port on your network node and duplicate it to another one. When you configure things like that, you have to make a choice. For example, here we are duplicating the interface Fast Ethernet 012, and you see after that we have a specific keyword with bus. The problem to take care here is nowadays we use full duplex communication. So we can have 100% of a bad switch coming from the switch to the host and to the host from the switch. So like you guess it, you may have a problem if you have heavy traffic. The idea is simple. We are gonna redirect two-way traffic to a one-way system from our switch to monitoring base station. So if we don't have a lot of communication, the switch can merge both traffic and be able to merge the two-way traffic into a one-way direction from the switch to the monitoring station. But if we have a heavy load, for example, you are troubleshooting a video stream or things like that, and you want the both ways, you may have a problem because the switch won't be able to merge the two communication, and you're gonna drop some packets. So in this situation, the only solution, the best solution is to use two network cards on your monitoring base station. So you're gonna duplicate traffic from one way to one card and the other way to another card. Or if you are on for example, on a gigabit network, you can also, if you want, buy a 10 gigabit network card. But I think this is cheaper. On more recent hardware, on more recent network switch and router, you have another solution which is to directly record the communication on it. So you have to have recent hardware with a lot of space on the flash card. Oldest one won't be able to store a lot of information, so it's not available on the oldest. But on recent and modern switch and router, you are able to directly capture the information on board, on the switch, and after that you grab your pickup file via SSH or via HTTP. this solution is really helpful when you are trying to do a remote debugging. So you have something happening on a remote network, on a campus, on another city, and you don't want to disturb someone with to go on your switch to plug a monitoring base station and things like that. You just want to grab the data. So this option is really nice for that. Of course, you can't do that with Apple Airport and things like that. Even if the Apple Airport is manageable, you don't have this kind of option on it. So most manageable hardware for the network can do that, but when it's created for the enterprise. So we have the endpoint, network node, and we have some solution from a wire. The first one is an active one, and it's basically a switch with pre-configured on factory to duplicate the information passing by. So it's just simply a switch already set up for you. And the other one is really nice. It's a passive one. It's just gonna link a transmit signal from an Ethernet cable to a receive signal to another one. So basically what you have on this stir, you plug your switch on the side, your target host on the other, and you have the two transmit signals were passively duplicated on the other Ethernet slot. And transient signal from your monitoring station are connected to ground, so it won't disturb the network. It's a passive solution, and it's basically undetectable. So if you have things like port security and things like that on your network, and you may have some problem to put some active solution on it, you can use that to do your packet capture absolutely transparently.
Does that knock the, pardon me for just jumping
Yep.
Does that knock the speed down to 700?
No.
Just because I thought when it's communicating on all 8 wires
Yeah.
per gigabit that you can't do passive because
I will check it, but I think it works. Well, I will check it. I will check it. Okay, so if we go back to the map, we have seen on the network node, we are able to do port monitoring and packet capture for some kind of hardware. On the wire, you are able to do active and passive network traffic duplication. And on the endpoint, we have TCP dump. On the endpoint, you can also use directly Wireshark, which is able to do live recording. But that means to install Wireshark on a production system, that may not be the good idea. So, now we have our data. Oh, sorry, yeah?
I've seen recommendations in the past not to capture directly with Wireshark because of potential bugs in its encoding stack. Is that still an issue?
I never seen any problem with it, but I use it only on my computer. So when on my computer I have to troubleshoot things, I do it directly with Wireshark, but I'd never use it on production system. So my experience on that may not be significant. And basically, it's not a good recommendation to do it on a live system with Wireshark. Use TCP dump with built-in on OS 10 and install Wireshark. We need the X server, X11, to your sysadmin system. So, traffic interpretation. Wireshark is nice. It is able to show you the information. So, really nice. But if you don't know what is the meaning of the host field, of the user agent field, of the HTTP communication, it's basically useless. So When you have to do your traffic interpretation, you have to understand what's going on because you have a problem behind. We have different sources of information to understand what does it mean. The most obvious are RFC and Internet Graph. That basically the standard used on Internet, so it's an open documentation. For example, for HTTP, you are able to read the whole documentation with big and go to the standard to understand what does this field mean. What does it mean if I have a 0 or 1 in this option and things like that. This is the main source of information. Another source of information is the source code. For open source product or in some kind of agreement, you can access to source code for closed source product. The interesting thing in the source code are the comments by developers. Sometimes you can find some really great information in source code comments led by the developer who are never be seen in the documentation. So this is really interesting for that because you have the most detailed information. And if you are able to read the code in front of you, you are able to understand what's the impact of specific option on the software you are trying to troubleshoot. And the last one, it's a last resort option, but it can be interesting too, is reverse engineering. Those time end up a lot of time on reverse engineering. If you look at some problem on the West End, you don't have the source code, and if you want to understand what's going on, you have to reverse the software to be able to understand, okay, how does it work, what kind of option it uses to create this network traffic on the output, and what is the impact of this kind of input traffic, etc. So it's a last resort option, but it can help too. If you have seen on the Mac Enterprise mailing list the current discussion about password server on 10.9 who don't read the external command, that's what I've used to understand what's going on. Use packet sniffing to understand what is out of the password server on the LDAP request, and use reverse engineering to understand why it's wrong. Some example now. 2 examples from me and 2 examples from friends. First one is linked to LDAP and the Cisco ESA, the Cisco box used essentially for VPN. The problem I got with this one is really simple. The Cisco VPN concentrator have support for LDAP, but it's more Active Directory LDAP. For example, we don't have support for POSIX group, only AD group. So my problem was I want to specifically authorize people linked to group membership for specific kind of VPN. And my idea was I should be able to set up specific LDAP sources pointing directly to my group and use the member UID as a filter field to do my authorization part. So if the LDAP return 0 answer, it's a no, at 1 answer, it's a yes. And it should work like that. Since it's not in the documentation, I've used here packet sniffing to check what's going out of the Cisco box and to see that, yeah, effectively, he used my parameter like I've expected. So yes, it should work and I shouldn't have any side effect. So this is a possibility with packet tracing. Use it to confirm that things work like expected and you won't have any side effect on your settings. So in that case, I was able to set a custom LDAP settings used for authorization only, not authentication, and it works like expected. Another one is linked to encryption. It's a hot subject nowadays, and basically, if you look at a network, an enterprise network or a university network, who is spread across a country, you have multiple campus, and you want to link them together, the most common solution nowadays is to use an MPLS one area network, wide area network. And it's basically a network operated by any or another network operator, and who is private to you. It's virtual, but it's private to you. And the problem you may have with that is communication going out your network and passing by this MPLS network here are in clear text. The network operator, if you want, is able to read your communication with packet sniffing and see what's happening on it if you don't have a protocol who do encryption on it. Usually, when we want to do encryption nowadays, we use IPsec. But IPsec in the standard have a lack of settings. It can do only tunneling or transportation, but it don't have the option to do router-to-router encryption. And that's what's the meaning of GetVPN with a Cisco-specific settings, using IPsec to do router-to-router encryption. And it's a really hard thing to configure, especially when you can't follow the documentation exactly, because you don't have enough material to do it. And basically, when you set up things like that, who are kind of complex to set up, and who have a big impact on the security of your network, your question at the end is, okay, I have an IP connection, but does it work for real? Is it really encrypted or not? And if it's encrypted, what are really encrypted? If I'm on an attacker point of view, what kind of information I'm able to get? So here, I've used my switch on the one side to create port monitoring simply and grab the data. And I was able to see effectively it worked for real. I have my network communication with encrypted, and like I wanted to, it's only the payload who is encrypted here. So if I look at the IP headers, I still see my source and destination, and what was interesting here, I still have my QoS flag. So I have multiple classes of traffic on my MPLS network to prioritize voice over data. And this information are kept by my encryption settings. So it worked like expected. That's another kind of solution of usage of packet sniffing.
Is the router-to-router encryption, is that layer 2 or layer 3?
It's layer 3. It's inside. When you use IPsec, it's layer 3. It's the IP payload who can be encrypted, and in kind of tunneling usage of IPsec, it's also the IP header. Some other example for other people this time. 2 examples again. The first one linked to LDAP too. And what's basically happening is these guys have a setup with web services, and each time a user logged on this web services, the LDAP server was almost dying. So they set up a traffic interception system to see what's going on, and they be able to discover that the web service was poorly developed, and at each login time, the service was dumping the whole LDAP tree. So when you have thousands of users, it can be problematic. Another one linked to IPNS, the Apple push notification services. Basically, we have the guy have an OS 10 server, linked to IPNS to use Profile Manager. It's really simple setup. And you have the other problem. Couple of hours after the start of the server, the IPNS don't work. And to make it work again, you have to reboot everything when you're on the network. So again, with packet sniffing, you was able to see that a couple of hours after the start of the APNS session, the router was just shut it down, the TCP session, and don't want to reopen it again. It was a low-cost router, low-end product, so that was basically a problem of consumption inside the router. And what you have done is just, okay, this router don't work, throw it away, get another one, more enterprise-ready and more properly developed, and the problem was fixed. So again, here, the traffic interception was really useful to see, okay, what's going on? It don't work like expected, and he was able to see, okay, it's my router who is poorly, and okay, I will use another one. That's basically the content of the session, and I have two bonuses who are not really useful all the time, but who can be fun to try. We have seen possibility to intercept the traffic on all this kind of network parts. But what about wireless communication? If the information is passing by a wireless system, are we able to intercept it or not? The simple solution is put your wiretapping system on the access point and you have your traffic. But if you want to play, you can also do it directly on the air by sniffing the wireless communication. You have some limitation on that. The first is it have to be a pressured key system. If you have a radius system, it won't work. The second one is you have to grab the unchecked packets when the client connects to the access point. Because in this period of time, you have some specific key or exchange between the access point and the client, and you need this key to decrypt the traffic. And the last requirement is very simple. You have to have the pre-shared key. If you don't have the pre-shared key, you are unable to decrypt the traffic. When all this information, all these requirements are met, you are able to decrypt the information. To do this kind of packet sniffing, you simply have to use, again, a built-in command line in OS 10, who is airport D. If we look at it, it's in /usr libexec airport D, and you have a lot of options here, and one of it is sniff. So you can target with your airport a specific channel on the air, and it will create for you a pickup file, basically. And after that, you can open it in Wireshark. So when you open it, by default, you only see 802.11 frame. You see the layer 2 frame. So here you have all information needed to troubleshoot problem linked to the media. So if, for example, if you always get the error message on OS 10 saying we can't join this network, for example, you can use this kind of techniques to see what's happening on the media layer and see what can be the source of the problem. And in Wireshark, if you enable the wireless option, you can set up the system with your decryption key. Okay, and it's not really stable system, so you have to play with the preferences. Okay, that's gonna be really simple to do. Okay, this one. It's the IEEE 802.11 preference in the protocol area. And you just have basically to play with the IV settings. And okay, now it have decrypted it, and I'm able to do a search on it. So I've just decrypt my information, my wireless information, and I'm now able to troubleshoot what's happening on my network, on my wireless network here. The last thing I want to show you is what you do when you have an iOS devices. You have an iOS devices who have network problem and you want to troubleshoot it. It can be on wireless, on Wi-Fi, on 4G, Edge, CDMA, a lot of things. How can you grab the data passing by your iOS devices if you need to do a packet sniffing on it? Does anyone have an idea?
Federate to a computer,
Yeah, and with command? Which command?
and then TCP on the TCP
Yeah,
on the
but
computer.
you need, oh, that's true. Okay, yeah. You can effectively connect it to, via wireless to an existing computer. So you can connect it to a wireless system who is managed by you and do your packet trace on the wireless system. That will work. But if the problem occurs only on the cellular network, when you are on roaming, you should have a solution. And this is basically what rvictl is made for. It's a built-in command line. It's a command line with installed with Xcode. So Xcode is available for free on the App Store. And with this command line, you are able to create a monitoring port from your iOS devices connected via USB to your Mac. So this is why I have my iPad here. So the requirements are you need an iOS devices connected via USB, and the computer have to be allowed on the device. So you know the pop-up saying, do you want to allow this computer to access to your iOS devices? You have to click allow on it. So rvictl, it's a simple system. You have to use the UDID to identify which device do you want to monitor. So this kind of information can be read on Xcode with the organizer. And here is my iPad. Here is the device identifier. Now I can do rvictl-s identifier. And now I have a new interface on my computer called rvi0. And here it is. And I can basically do, as before, TCP dump -i i0 desktop. Where am I? -w desktop and iOS.pkep. So he is recording it. I will do some traffic. Okay. Again, Control C to stop it. And now in Wireshark, okay, here is my network traffic from my iOS devices. And it will work if it's on wireless, on a Wi-Fi, or on a 3G or 4G network, etc. So, for example, if you have a problem with your Exchange setup, you work on the inside and not on the outside. You are able to see what's going on here. And to stop the packet sniffing, it's simply -X. Sorry. Okay. Wireshark is able to connect directly to an RVI port. So I could be able to use Wireshark with my RVI 0 interface, but it works out of the box for 10.8 and before. But on 10.9 you have a problem, and it's not really a problem, but you have to play with the settings because rvictl don't create a real pickup file. It creates a pickup file, but with some additional headers, and you have to configure Wireshark on 10.9 to be able to read it properly. But if you use TCP-DUM to do your packet sniffing, it will just work out of the box. So use TCP-DUM directly, and it will work fine. If you have liked this talk, you may take a look at the talk by Josh Marlon tomorrow on DINS Hall 1. What's the way wrong with my server? I think he's going to talk about this kind of techniques as other one. You?
Hi, I'm Josh. Thanks for the plug. I have to say, after running through my slides again last night, I'm just not going to have time for the packet sniffing demo. So I really appreciate you talking on this with me anywhere near as good as
Okay. So this is the end. So don't forget the feedback URL. And if you have any question, or if you want to talk about your experience with that, or your current problem, feel free. Yeah, the mic.
You mentioned calling airport D. Is there any difference between using airport D and the regular airport command line tool with packet sniffing?
The regular airport command line?
Mm-hmm.
Which one?
It's in private frameworks, 802.11.
This is the same.
Okay. The man page
no,
for
it's-
airport D says not to call it directly.
I don't care.
So there should be no difference because they do appear to be different binaries.
Okay. The things, what is used here in Airport D, it's the same backend as in. I don't know if you have already used that, but if you click on Option here, when you click on the wireless spot, you have wireless diagnostic, and Airport D is what is used by wireless diagnostic. So it should work. And you should be able also to do your packet sniffing on wireless with this GUI. And to be honest, I don't really follow any kind of documentation. So question related to official support, I won't be able to answer it.
How effective have you found using like port mirroring at the switch level to do this type of packet sniffing for an active server? I mean, is the port mirroring going to slow down a live server too much to do that, or?
If you do your port monitoring on a switch, no, it will don't slow down unless it's a shitty box. But from most hardware, it will don't slow down it because it's only copy. It don't read anything on it. It just duplicates the information so it won't be a problem. I think TCP dump is more impacting on a production server than the thing on a network node.
So port mirroring with TCP dump would be a better way to work on a production.
Yes, yes. One thing to be careful is when you use not port monitoring but packet capture on board, be careful to your resource usage. It can be a big problem if you have too much data to store, and on most systems you have settings to say, okay, my buffer is that long, and what I do when I reach the end of the buffer? Do I start again or do I stop it? So it's kind of settings to be careful when you set up a packet capture directly on a Cisco box.
Can you review over the options that you have with encrypted traffic where you don't have the keys and you don't have certificates? For example, talking to Office 365's hosted exchange.
I don't know if I should. Not the administrator of one administrator of the server end. It's simple. I have the private key of the certificate, so I can use it. But if you aren't the administrator of the server side, you can do what a lot of companies do nowadays. I don't know in the US, but at least in France, it's sadly start to be pretty common. It's create an inside certificate authority, make it work on your client, and simply do a man-in-the-middle attack. We have in France, sadly, a lot of big companies who do that. We have security devices on the edge of the network who gonna replace all kind of SSL communication and just terminate it officially for the real server on the network edge and create a new SSL encryption on the inside with our private keys, our certificate, so it will be trusted on the end, but it's not a real certificate. So we can use this kind of techniques to have a small amount of clear text communication on our network edge. Does that answer your question? So,
I mean, it was kind of a loaded question because we had to sniff Office 365 hosted exchange traffic, and the product that one of them is Charles, which is essentially a man-in-the-middle attack, and there's another Windows product whose name escapes me that they also recommended.
Yep. And if you want to look at Windows tools to do that, and to do it really simply, look at Abel and Kel. You know the two guys from the Bible, Abel and Cain. This is a really great tool to do nasty things with Windows clients.
I just want to say that generically, it's an SSL forward proxy. So if you're looking for maybe other tools that do the same thing, that's what you want to look for.
Checking for updates?
Yes.
Because they moved to HTTPS as of 10.8.
Yeah.
And I, for whatever reason, can't follow the traffic of, hey, how do you get from what it used to be just SWScan and plain XML?
Okay, no, I didn't look since 10.6. So,
Okay.
sorry. Maybe someone else has the answer.
I'm sorry. And to follow up on that, so we do that on our enterprise network that we have. Hey, Firefox won't work at all talking to Gmail, for example, until you install in Firefox's certificate authority. But Chrome doesn't have that problem. So is it because of Speedy or is it because of IPv6, do you think, that Chrome, for whatever reason, just does not care that you don't have that man-in-the-middle, essentially CA, root CA installed.
Did you check that Chrome is seeing your certificate or the other?
This is before that certificate gets installed. Gmail works. Has no
Yeah,
problem.
but when you look at Chrome,
Yes.
did you check that in Chrome the certificate who is read with loaded on the server is it a good certificate? Is it your inside or is it the Gmail one? Check that. Maybe it's because of IPv6 or other thing. Maybe it's your proxy box who don't do the job and just let the communication passing by. You have to check what certificate is loaded here in this case.
And also, what type of data plan do you have that you can do sniffing when you're in the States? You must be roaming when you're doing your iPad
No, I'm
demo.
connected on the wireless.
Oh, okay. Thank you.
I'll just add a little bit to what you're saying. If you're trying to diagnose that it's got, and you can decode that using OpenSSL, make sure it's sending the certificate you think it's sending. We had situations where it's sending a default certificate and with it some self-signed instead of the certificate that you think you installed. So that's one thing you can do, and that's sort of. And I think that Wireshark could also decode that certificate exchange as well.
Yeah, if you put the private key inside. Yeah. Any other question? Or feedback or anything?
You can also, without having to use rvictl, if you hotspot, you can.
Yes.
directly-
Yeah. If it's connected to your infrastructure, you can do it. Yes, of course. rvictl is useful when you want to troubleshoot on a cellular network.
No, that's what I mean. I'm hotspotting via.
Yeah, but if you're hotspotting it, you won't be able to see the iOS traffic by itself.
Oh, okay. That makes sense.
So, thank you.
All done?